Welcome to Across the Globe. Today we will learn about unsupervised learning basics. Unsupervised learning in machine learning refers to a model operating without labeled data for prediction. Its primary objective is to uncover patterns, relationships, or structures in the dataset. This form of learning is frequently utilized in clustering methods like grouping similar customer segments based on purchase behavior, dimensionality reduction, such as reducing the number of variables in financial data analysis, and anomaly detection, like identifying fraudulent transactions in banking transactions without prior knowledge of such instances. Unsupervised learning includes techniques like clustering, aiming to group similar data points without labeled target outcomes. K-means clustering is an instance where data is divided into clusters based on similarities. In real-world scenarios, such as customer segmentation in marketing, K-means helps categorize customers with comparable behaviors or preferences into specific groups for targeted strategies. By using the provided Python code snippet, the K-means function from sclern.cluster is employed to execute K-means clustering, enabling data grouping into a specified number of clusters. Dimensionality reduction is crucial in unsupervised learning to decrease the number of features in a dataset without losing critical information. Principal component analysis, PCA, is a common technique used for this purpose. For instance, consider a dataset with numerous variables measuring similar trends such as temperature, humidity, and wind speed. PCA can compress these variables into a smaller set of principal components without compromising the underlying patterns. In Python, utilizing the PCA module from scikit-learn allows transformation of high-dimensional data into a reduced form by specifying the desired number of components. One common use of unsupervised learning is anomaly detection, which focuses on identifying outliers or irregularities within a dataset without the need for labeled data. An illustration of this is density-based anomaly detection, wherein anomalies are identified based on their deviation from the density of the surrounding data points. In practical terms, to implement density-based anomaly detection in Python, one can utilize algorithms like isolation forest from the scikit-learn library. By creating an instance of the isolation forest class and fitting it to the dataset using the fit_predict method, anomalies can be detected based on their isolation from the majority of the data points. Unsupervised learning is like organizing a messy room without any instructions or guidance. Just like sorting through a pile of clothes to group similar items together without any labels, unsupervised learning algorithms group data points based on similarities. In a program, unsupervised learning can be implemented by using clustering algorithms such as K-means or hierarchical clustering to automatically divide data into categories based on patterns. Hey Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code begins by importing the necessary libraries: NumPy for numerical computation, K-means from scikit-learn for implementing the K-means clustering algorithm, and matplotlib.pyplot for data visualization. Next, sample data X is created containing 6 data points with 2 features each. These data points represent coordinates in a 2-dimensional space. The K-means algorithm is instantiated with n clusters equals 2, indicating that the data should be grouped into 2 clusters. The algorithm is then trained on the data using the fit method, and predictions are made on the same data using the predict method to assign each data point to a cluster. The data points are plotted using plt.scatter with colors assigned based on the predicted cluster labels yk-means. The cluster centers are also plotted in red at the calculated positions. This visualization helps in understanding the grouping of data points by the algorithm. The output of the code is a scatter plot showing the original data points grouped into 2 clusters, and the cluster centers highlighted in red. This visualization provides insights into the natural groupings present in the data without the need for labeled examples. Real-world example application/use case. One practical application of K-means clustering is customer segmentation in marketing. By analyzing customer data such as purchase history and demographics, businesses can use k-means to group customers with similar behaviors or characteristics. This segmentation helps in targeted marketing strategies and personalized customer experiences. One industrial example of using unsupervised learning, similar to the k-means clustering algorithm shown above, is in customer segmentation for marketing purposes. By clustering customers based on their purchasing behavior, companies can tailor their marketing strategies to different customer groups more effectively. Another real-world application of unsupervised learning is anomaly detection in cybersecurity. By analyzing network traffic data or user behavior logs, unsupervised learning algorithms can identify unusual or suspicious patterns that may indicate a potential security threat. Across the globe, industries are leveraging unsupervised learning techniques to make sense of complex data and drive valuable insights for decision-making and problem-solving. Keep learning, stay curious, and I'll catch you in the next video.